Mercury. Due to its location, rotation, and physical properties, Mercury remained difficult to study for a long time. However, even limited observations have revealed astonishing facts. You might think, what do we care about that little guy? But no. Mercury plays a vital role in understanding how gravity works, how natural processes form planets, and how they evolve. This planet deserves special attention, and we're about to prove it to you. Here are 5 amazing facts about Mercury. A day longer than a year. The fact that a day on Mercury is longer than a year sounds paradoxical, but it's true and is related to the peculiarities of its rotation around its axis and its orbit around the Sun. Mercury rotates very slowly. One complete rotation takes about 58.6 Earth days. It means that one Mercurian day, by Earth standards, lasts nearly 2 months. At the same time, Mercury's orbital motion is swift. It revolves around the Sun in just 88 Earth days, making its year the shortest among all planets in the solar system. Seems like no big deal, but there's one more critical nuance. When we say day, we mean a solar day. That is, the time between 2 consecutive solar noons, the moment the Sun is at its highest point in the sky. Because Mercury rotates around the Sun and its axis in a special ratio, the so-called 3:2 orbital resonance, meaning that Mercury completes 3 rotations on its axis for every 2 orbits around the Sun. This solar day is longer than its orbital period. Because of this, on Mercury, you could observe the Sun rising, then dipping back down slightly, and then rising again. Would you like to see something like that with your own eyes? Why is that, you may ask? This resonance is the result of tidal forces from the Sun. These forces gradually slowed Mercury's rotation over millions of years until it reached this stable resonant state. Mercury has no atmosphere. Mercury has virtually no atmosphere in the usual sense of the word. Unlike Earth, Mars, or even Venus, there is no dense layer of gas around Mercury that could retain heat, protect it from meteors, or maintain atmospheric pressure. What it does have is more correctly called an exosphere, an extremely tenuous environment made up of individual atoms constantly escaping into space. Essentially, it's a vacuum. There are several reasons for such a weak atmosphere. Mercury is tiny and therefore has a weak gravitational field. It's not strong enough to retain light gases near the planet's surface for long periods. Moreover, the planet is extremely close to the Sun, so intense solar radiation and streams of charged particles constantly bombard its surface. This so-called solar wind blows away gases from the surface. Even if some atoms are released, for instance by meteorite impacts, they stay near the planet only briefly, as they don't form a stable layer and don't interact with each other like a proper atmosphere would. The composition of this exosphere is inferior and rarefied. Scientists have detected traces of hydrogen, helium, oxygen, sodium, calcium, and potassium. But their concentration is so low that the exosphere of Mercury is billions of times thinner than Earth's atmosphere. This extreme thinness means Mercury has no atmospheric pressure, no winds, no rain, and no clouds. Its surface is in direct contact with outer space and sunlight. Lovely, isn't it? A day longer than a year and beautiful weather too. But because of this, the temperature on Mercury fluctuates dramatically. During the day, when the Sun shines directly on the surface, it heats up to over 430 degrees Celsius. At night, with no layer to retain heat, the temperature plunges to -180 degrees Celsius. It is one of the most extreme temperature contrasts in the solar system. Mercury has no friend. Mercury is one of 2 terrestrial planets that have no natural satellites. It sets it apart from most other planets in the solar system. A few factors explain the lack of moons around Mercury. First, the Sun's gravitational pull strongly dominates the nearby space, and any objects that might orbit Mercury would be under heavy solar influence. Because of this, a stable satellite orbit near the Sun is extremely hard to achieve. since the sun's gravity could eject a moon from orbit or consume it entirely. Second, as we just mentioned, Mercury is a relatively small planet with a weak gravitational field. It means its gravity is too weak to hold a moon in orbit. If Mercury did have moons in the past, they may have been pulled into the sun due to close interaction or flung out into deep space. Mercury is smaller than some moons of the giants. Mercury is the smallest planet in the solar system, among the 8 officially recognized planets. Its diameter is about 4,879 kilometers, making it smaller than some of the largest moons of other planets, such as Ganymede, Jupiter's moon, approximately 5,268 kilometers, or Titan, Saturn's moon, approximately 5,149 kilometers. Mercury's small mass and size lead to a relatively weak gravitational field. It affects the planet's ability to hold an atmosphere or satellites, as well as its internal structure. Despite its small size, Mercury has a very high average density, indicating that it is made mainly of metals and heavy elements. Mercury earned the title of the smallest planet after Pluto was reclassified as a dwarf planet in 2006. But no need to pity Mercury. This fact makes it unique. Its small size and proximity to the Sun create conditions unlike those on any other planet in the solar system. Why is Mercury so small? The answer lies in several factors that influenced it during the early stages of solar system formation, more than 4.5 billion years ago. Mercury formed very close to the Sun. In the inner part of the protoplanetary disk, the cloud of gas and dust from which the planets formed, temperatures were much higher than farther out. Materials that were key in building up the mass of other planets couldn't condense so close to the Sun. There's also a hypothesis that Mercury was once much larger, but suffered a catastrophic collision with another large body. As a result, its outer layers may have been partially or almost entirely ejected into space. What's left of Mercury is a small world with a massive metallic core. This theory fits well with Mercury's high density and the large size of its core, which takes up about 85% of the planet's radius. Mercury confirms general relativity. The existence of Mercury was confirmed in ancient times, but its motion and peculiarities were fully understood only recently. Back in the 19th century, astronomers noticed that the perihelion of Mercury's orbit, its closest point to the Sun, shifted slightly faster than could be explained by Newtonian classical mechanics. After accounting for the gravitational influence of all the other planets, the expected shift was around 531 arcseconds per century, but actual measurements showed 574 arcseconds. This difference of 43 arcseconds per century puzzled scientists and sparked heated debate. Some scientists even proposed the existence of an unknown planet, which they named Vulcan, as the cause of the discrepancy. But no evidence of such a planet was ever found. Everything changed with the appearance of Einstein's general theory of relativity. When the new theory was applied to Mercury's orbit, scientists were astonished to find that the equations of general relativity precisely predicted the extra 43 arcseconds per century, exactly the discrepancy classical physics couldn't explain. This became the first precise experimental confirmation of general relativity. Mercury's behavior in the Sun's gravitational field turned out to be so sensitive that it became a kind of laboratory for testing new physics. Thus, Mercury played a key role not only in astronomy, but also in the development of 20th century theoretical physics. Well, that's all for now. Subscribe to the channel, leave a like, and help Mercury find some friends already. He's a bit lonely out there. See you next time.